You've surely thought about space at some point or another, and if you follow that rabbit hole far enough, you inevitably end up just confusing yourself. Even the concept of a light year is a bit much for our brains to comprehend, so try 700 million of them. Do you see? It's bewildering you even now. However, there is a gigantic 330 million light-year wide gaping hole called the Boötes Void out there in the big black, 700 million light-years away, that is completely and totally baffling scientists. This is everything you need to know about astronomers finding a gap in the universe that defies all logic. Welcome back to Space Infinity. If you want to know where you're going, you need to know where you came from. The importance of history. In 1981, Robert Kirshner was hard at work with a team of astronomers at the University of Michigan, calculating redshifts. What are redshifts? They are a measurement of how fast something is moving away from our home planet Earth, because as we know, the universe is expanding. Redshifts are the unit of measurement that describes the speed at which something is moving away from, because if we can calculate that, we can actually get a fairly accurate map of the universe. Kirshner and company were trying to do precisely that, and so they were looking to work out the redshifts of multiple different galaxies. As this map began to take form and get fleshed out, something strange came to the attention of the team. At a distance of 700 million light-years from our blue bauble, a gigantic black void was present. In an approximately spherical region about 300 million light-years wide, there was almost nothing, hardly any galaxies, and nothing else at all to note. Kirshner et al. Published that within the void they were only actually able to detect 8 galaxies in 1987, and Hakera and Strauss announced a year later that they had detected 3 more. By 1989, we had discovered up to 15 galaxies in the void, and by 1997, it was announced that the Boötes Void contained at least 60 galaxies. If you're thinking that is a lot of galaxies, then think again, because a space covering 300 million light-years would usually have about 2,000. Of course, as mentioned, 330 million light-years is a space so vast that it's virtually impossible for our brains to comprehend. So here's a handy example. Our galaxy, the Milky Way, is about 100,000 light-years across and contains between 100 and 400 billion stars. Of course, the void is spherical, and so our galaxy could fit into it billions of times. The area was dubbed the Great Nothing, but later became known as the Boötes Void, thanks to its location in the constellation of Boötes, the herdsman with the plow that supposedly drives around the North Pole. The void is so completely vast that astronomer Greg Aldering actually stated an interesting piece of information that you won't believe. He said that if the Milky Way galaxy had been in the center of the void, it would have taken humanity until the 1960s to work out that there were actually any other galaxies in existence. Clusters, threats, and voids. Of course, as maps and universal surveys and the methods of accomplishing them have grown more and more sophisticated, we now know that galaxies are arranged a bit like a giant web. Most of the galaxies in our universe are located in long celestial structures, called filaments, that actually can be found winding around the cosmos. When these filaments meet, they create regions in space that have a very high concentration of galaxies, and we call those areas clusters. However, between these filaments, or threads, you will find massive empty voids that contain almost no galaxies to speak of. The voids are actually about 80% of the known and observable universe, and a lot of them are between 30 to 300 million light-years across. Boötes is one of the biggest in the universe, which has earned it the nomenclature of supervoid. This is something that could be debated, however, because of the fact that the eerily gigantic nature of the Boötes Void is considered by scientists to be formed as the result of smaller voids, possibly several of them, merging together with each other. The beginning. The voids are thought to exist due to the circumstances of the origin of the universe. In the first days that the cosmos existed, all the universe was still very tightly packed, and this is considered to have been kind of a uniform soup of matter. But then, random quantum fluctuations would create equally random changes and difference in how the matter was distributed about. Some areas of the universe would have then been denser than others, and this means that they would have had a greater gravitational pull, in which case, matter would be pulled towards them rather than remain in the less dense areas. This then means that they became even more dense, thus increasing their gravity once again and attracted even more matter. This all happened as the universe was greatly expanding, and so the fluctuations that probably began on a quantum level most likely eventually occurred on the scale of hundreds of millions of light years. The smaller piles of matter then arranged themselves into galaxies, and the stars, planets, and other phenomena therein. Thanks to developing the ability to study these colossal structures, astronomers have become able to gather a lot of information about what the universe likely looked like in its beginning phase. Thanks to super advanced telescopes like the James Webb Telescope and increased imaging technology, we can create much more detailed versions of Kirshner's maps. For an example of this, look at the Dark Energy Survey that has mapped about a quarter of the southern sky and examined about 300 million galaxies. The thing that makes the Boötes Void so significant, though, is that there is absolutely nothing about it that makes it significant besides its size. Yes, it is gigantic, but there is nothing weird or wild about its behavior. And there's always the potential that we might find an even bigger void one day. More research into the arrangement of filaments, threads, clusters, and voids has led scientists to believe that the young universe had a seamless structure when the Big Bang occurred. This means that the universe that was created by the event wasn't so much a cloud of energy, but already organized structurally in a similar way to how the universe is now. The only difference would be that it was less concentrated. The reason we can say this is that the Boötes Void actually has matter, tons of it, right in the center of it. This means that the matter has not had long enough to make it to the edges of the void, and this shows that if the universe was in fact an equally distributed cloud of matter at the time of the Big Bang, then voids would not exist. Instead, the matter that was in close enough proximity to other matter has organized itself into galaxies, while voids have only grown bigger. Boötes as a void has often been associated with the image of Bernard 68, a dark nebula that is impossible for light to pass through. And in fact, images of Bernard 68 that have been captured are far darker than those of Boötes. Unlike the void, Bernard is actually a physical mass, which does not permit light to penetrate or pass through it. Sim universe. Thankfully, because of the developments of our own technology here on Earth, we now have supercomputers that pack enough power to simulate what would likely have happened in the first moments after the Big Bang, and how it became the universe as we, just barely, understand it. When we compare Kirshner's and other maps to the data from these simulations, astronomers are greatly helped in understanding how the universe was formed. And of course, thanks to the data we accumulate, we have learned that the circumstances were in many ways very different from what we discovered back then. So, while our minds might not be able to exactly comprehend or accurately mentally consider what the true size and nature of the universe is, because it is of course so radically different from our own scale living here on just this one planet, a computer is absolutely able to think in terms of astronomical numbers. The units of measurement that a computer can handle means that it will be able to predict the true size, shape, and nature of the universe more accurately. Thanks to this, our ability to learn more about phenomena like the Boötes Void will only increase as technology does. And this means that we will only come to understand it more as time continues to pass. But what do you think about the Boötes Void? Does its existence bother you or excite you? Are you interested in learning more about how the universe first began? Make sure you've subscribed to Space Infinity and have viewed the video archive after you've hit that like button.